Reciprocal of cosine is? Reciprocal of tangent is? All right, so we can handle that. We know that definition. If I give you a triangle, if I label this, we know angle A is across from side A, side B is across from angle B, this would be side C. If I asked you for sine of angle A, what would that be?
A over C.
Opposite over hypotenuse. If I asked you for tangent of angle B, right. Here's angle B, tangent opposite over adjacent, so B over A. If I asked you for cosine of angle B, cosine is adjacent over hypotenuse, so if I'm viewing from angle B, that's A over C. What if I asked for cosine of angle A?
B over C.
Right. So if I gave you questions like this, could you handle those? I want to do, either at the end of class today or at the beginning of class tomorrow, I want to do like a really short quiz. Okay, there's not very many questions. There's 6 questions like this. Basically, I'm going to tell you sine, cosine, tangent, cosecant, secant, cotangent, and you just fill in those. Then there's 6 questions like this. I'll give you a triangle and just ask for, like checking, can you do those ratios? Can we handle that? The other thing that we have been working on is that table. You guys remember our table that we've done several times? You should have a blank one somewhere because I gave you multiple copies. At this point, I wouldn't put the whole table on here, just like the first 3 rows, sine, cosine, and tangent. Has everybody found one of those blank tables? So see if you can fill in the first 3 rows, sine, cosine, and tangent. So more hand trick. Remember, sine is the square root of the top over 2, cosine square root of the bottom over 2, tangent square root of the top over square root of the bottom. So 0. Sine is 0. You get the square root of 0 over 2, which is 0. Cosine is the square root of 4 over 2, which is 1. Tangent, square root of 0 over the square root of 4 gives us 0. 30, sine, square root of 1 over 2 is a half. Cosine, square root of 3 over 2. Tangent, square root of 1 over square root of 3 is a radical 3 over 3. 45, sine, square root of 2 over 2. Cosine, square root of 2 over 2. Tangent, square root of 2 over square root of 2 is 1. 60, sine, square root of 3 over 2. Cosine, square root of 1 over 2, so 1/2. Tangent, square root of 3 over square root of 1, square root of 3. And at 90, sine, square root of 4 over 2 is 1. Cosine, square root of 0 over 2 is 0. Tangent, square root of 4 over the square root of 0, undefined. How do we do on that? Okay. So do we think we would be okay to take a quiz like this? Should be like the easiest quiz points you've ever earned, right? I've told you exactly what it is, but I want to make sure that we are learning these values and not just trying to put it off and hope that it comes later on. All right, any questions about that? Notice a quick check. We've talked about cofunctions. The sine of 0 and the cosine of 90 are the same. Sine of 30, cosine of 60. Sine of 45, cosine of 45. Sine of 60, cosine of 30. Sine of 90, cosine of 0. So sine and cosine should just be in reverse. Does that make sense? So let's do some notes now. And then we might do that at the end of class today, or if you feel really uncomfortable with doing it today, I'm okay with letting you do it tomorrow. But I would just like everybody to do that so I can make sure we're on track. Today we're going to start talking about solving right triangles. That means like finding all the measurements in a triangle, all the angles and sides. With this, we use significant digits. For the homework today, I'm going to have you do it with significant digits. But after that, like a test or a quiz, I would tell you specifically answer in significant digits or not. A lot of times we just go to 3 or 4 decimal places. Significant digits has slightly different rules. You've done significant digits in your science classes probably, so you might have heard it before. It begins with the first non-zero digit on the left and all the digits following. Trailing zeros don't count unless you have a decimal point. So if I ask how many significant digits this is, it's the first non-zero digit and everything after that. So how many? 2. All right, here, first non-zero digit and everything after it. So that's 3. If you have a decimal, we count the zeros after it. So this one would be 4. This one, 5. But 700, do I have a decimal? So only the 7 is considered significant, so that one is 1. So the idea of significant digits, it basically has to do with rounding. You can't give me an answer more accurate than the numbers I gave you to start with. For instance, if I gave you numbers where I already rounded everything to the nearest 10, can you give me something that's accurate to the nearest 1? No, because your first numbers were rounded. If you are looking in the book, which I'm sure you guys do, you go home and read the book to make sure I didn't lie to you, right? They give you all these rules, like how many significant digits you should do for everything. Here's my rule. Match the significant digits given in the problem. Okay, so if I give you 2 significant digits in the problem, and I tell you to answer in significant digits, give me 2 significant digits in your answer. If I give you 2 numbers in the problem and one is 4 significant digits and the other is 3, you have to go with the smaller number. So you match the smaller number of significant digits given. A few assumptions. From now on, if I say right triangle ABC, we're going to assume C is the right angle, unless I tell you otherwise. We'll round to our significant digits. Don't round in the middle. If we're doing a 3-step problem and you round 3 different times in that problem, your answer is going to be off by quite a bit. So try to only round at the very end. All right, on this, I really have 4 types of problems, and I think I did like A, B, and C, 3 examples for each type. We don't have to do all of them. We'll do as many or as few as you guys need, okay? So if I asked you, in right triangle ABC, angle A is 40 degrees, and side C is 12 centimeters. Find everything else. So I always start with a picture. I'm a little more visual. I need a picture to know what I'm doing. And I told you assume C is the right angle. So angle A is 40 degrees. Side C, where do I put side C? The hypotenuse is 12 centimeters. I need to find side A, side B, and angle B. What's the easiest thing to find right now?
Angle B.
Mm-hmm. How would we get that? We know in a triangle all the angles add up to 180. So you could do 180 minus 90 minus 40, or you could know these two just add up to 90, so 90 minus 40. Either way, and we get 50 degrees. How many significant digits is that? 1. What I want you to do is just keep all of your angles to the same significant digits. How many significant digits did I give you on my side? 2. So let's do all of our sides to 2 significant digits. All right. So side A is right here. From angle A, side A is opposite. 12 is, what trig function involves opposite and hypotenuse? So I could say the sine of 40 degrees equals the opposite side A for the hypotenuse 12. If I want to find A, what would I do?
Plug in the sine of 40 degrees and make it equal to A over 12.
Since I don't want to round too much, sine of 40 isn't going to come out nice. I'm going to go ahead and multiply the 12 first, and then just type the whole thing in my calculator. Now, make sure your calculator is in what mode? Degree mode. So remember that mode button up by the second. Make sure you're in degrees. And then you can just type in 12 sine of 40. So we get 7.713, but if I'm doing 2 significant digits, what would I call it? 7.77. All right. On these problems, I'm going to make a request that you show me a little bit of work. Because didn't we just round 7.7 quite a bit? Yeah. You could get side B a couple different ways. You could do Pythagorean theorem, or you could do another trig function. I don't care how, as long as you show your work. Because here's the thing. When we are using rounded numbers to find the next number, it might change it slightly. So your answer might be a tenth different than my answer key, because you found it a different way, and you used a rounded number to get that. I'm okay with it as long as I know how you got your number and I understand and see the difference. Does that make sense? So these problems are different methods. Unless you keep all the decimal places, you could get a slightly different answer due to rounding rules. Just show enough work that I know how you got it and I can check it. If I wanted to use a trig function to get B. So from A, B is adjacent, 12 is hypotenuse, so that would be adjacent and hypotenuse, what trig function? So I could say the cosine of 40 degrees equals B over 12. Multiply over my 12. 12 cosine 40. So if I do 2 significant digits, what would I round that to? This one, if you dump Pythagorean theorem, it does work out for the same, but sometimes there's a slight difference. It shouldn't be a big one. All right, so we found all the missing pieces. Is that one okay? I want you guys to do the one right beside it. So I'm not even asking for everything this time. All I asked you to find, let's see, make sure I picked the right one. Okay. So find side A. Does everyone know where to label side A in this? Where does it go? It's across from angle A, so in between angles B and C. So from the angle I know, the 24.5, this is adjacent and that's hypotenuse, so what trig function? So cosine of 24.5 degrees equals A over 2.34. So if I multiply that over 2.34 cosine 24.5. How many significant digits should I use? 3. So I get 2.1293. If I round that to 3 significant digits, what would I say? 2.13. that okay? Do I need another problem like this, where I give you an angle inside and we find what's missing? Let's go to example 2 for now. We can come back if we decide we need another one. So this tells me in right triangle ABC, side A is 2.73, so that's across from angle A. Side B, so across from angle B, is 3.41. Find the remaining sides and angles. Use degrees and minutes for the angles. Okay, so I have to find side C, angle A, and angle B. Let's start with that side. How would I find side C?
It's just 90 degrees.
That's angle C, yeah. But for my side, I could do, since we have a right triangle, Pythagorean theorem. A squared plus b squared equals c squared. So if I type in my calculator, 2.73 squared plus 3.41 squared. And we square root, we don't have to worry about plus or minus, we're dealing with all positive sides here. How many significant digits do we need? 3, so I would call this 4.37, and I didn't give any units here. All right. Now I need an angle. I only have the right angle here, so we can't just subtract from 90. If I want angle A, let's use a trig function. This is my opposite side and that's my adjacent side. What trig function uses opposite and adjacent? I could say the tangent of angle A is equal to 2.73 over 3.41. How do we find an angle in our calculus? Yes. So you are going to type in tangent inverse. So that's second and then the tangent. Okay, so I get 38.68029. Now, on your homework, I am fine with the decimals, but in this one, just because I figured it was a good chance for review, I said use degrees and minutes. So that's 38 degrees. How do I get my minutes? Right, just the decimal part times 60. How many significant digits were given in the problem? We had 3 in the problem, so I need to answer this to 3 significant digits. I already used 2. This rounds to 38 degrees, 41 minutes, but how many significant digits is that? 4. So if I only want to do 3, you would say 38 degrees and 40 minutes. How could I get angle B? You could do another trig function, opposite over adjacent again, or you could know A and B add up to 90, so you could do 90 minus that. So remember borrowing, this is 89 degrees, 60 minutes. So we get angle B to be 51 degrees and 20 minutes. that one okay? Let's try one. So in right triangle, ABC. Side C, so opposite of angle C, is 45.54 feet. Side A, so across from angle A, is 23.32 feet. How would I find angle B? So the cosine of angle B equals my adjacent side, 23.32, over my hypotenuse, 45.54. So to find the angle, we do the inverse. I didn't say you had to do degrees and minutes, so degrees is fine, but how many significant digits do we need? 4. So 7 would round that up, so I get 59.2, and I would need to go ahead and put the 0 there to give me my fourth significant